So the first thing that we are going to do today, and I hope everyone can see my screen. Let me know if you can't see this. First thing I wanted to do is show you a completed sample file of a VRF model in EnergyPro. I'm going on the assumption that most of the people here are fairly new to EnergyPro. So after I show you this completed model and what it's supposed to look like, we're going to build one from scratch, showing you the inputs that you need to use and how to get those in there. And then I'll show you some of the reports and the calculations, and then kind of open it up to questions. So first of all, I hope you have EnergyPro. I hope you can maybe follow along on your screen with me. If not, that's fine. You can always download it later. The software is available for download at energysoft.com. And all right, I'm getting a message that the screen is too small. Does this look better? Ali is saying that the screen is too small. I can try that. Hopefully that's better. Okay, it's better. So yeah, you can download the software from energysoft.com. It will be a demonstration version until you have purchased it. There is a purchase online via PayPal link on our website. You can also contact sales to have them help you purchase it. Sure, I'll speak up. Sorry, Austin. So once you have the software on your screen, you can open the sample files, which are available in the projects folder. You just need to go to Open, and then your projects folder will be located in the My Documents, and then EnergyPro 5. I have it saved here on my desktop. But there are a number of sample files here. The VRF and VRV sample files are labeled with the Mitsubishi or the Daikin or the LG. So I have one already open. It's here. And you can see that once you go into the central system icon, there will be a next to the new system, there's a list of all of the central systems from that manufacturer. So we have that here, and we're going to go over how to build this model in a few minutes. I just wanted to show you that if you want to open a sample file, this is where you do that. And then, as well as the central systems, in the zone icon, there is, under the mechanical tab, a list of zonal systems from the manufacturer located here. The VRF systems are not in the default library. The VRF systems are located in the sample files, and what you'll have to do is you'll have to export the central systems and the zonal systems from the sample file to your project. And the way you would do that is you'd have two projects open, the sample file and your project file, and then from this library select the systems that you want to export, and then you could export it to the default library, or if you had another file open, it would be listed under default library here, and you could export it to that the library of that project. I hope that answers your question, Austin. Okay, so what we're going to do now is we are going to actually build a model from scratch. So I'm going to close this. We are going to open up a brand new file. You can either go File and New, or just in the toolbar here, Open a New File. And you're going to have just a blank building here. First icon is the building icon, where the general information goes, such as the location. So I'm going to choose a location there. And then the building name, sample file is what we'll call it today. Is it a new building? Job number really comes from your office, or however you label jobs in your office, or personally, that's how you'll do it there. And then project title and architect and lighting designer really is just documentation. It's not going to affect the calculations, but it'll show up on the reports. Under the Utilities tab, you select your utility rate information here. You can create your own utility rates if your utility rate isn't in the import button. We have a number of utility rates here, especially in California, but we don't have every utility rate in the country available. So if you did want to create your own, you just click on utility rates, enter the information here, and then you'd have that there. Notice that there are electricity and fossil fuel utility rates. If you're going to be doing any kind of economic analysis, you need to put these utility rates in, because otherwise the program won't know what the energy is costing. No, there's really no way to put that number on there, to put the engineer of records PE number onto the report. You can type it in after your name if it fits, but otherwise you'll just have to write it in there. So once you have the general information input for the building icon, you're going to add the plant icon. And in EnergyPro, whenever you want to add something, you right-click onto the icon and then select Add Plant. It'll show up as an undefined plant. You highlight that there, and now you're going to input the domestic hot water and heating hot water, as well as the chilled water information into this plant icon. If you're modeling a building with only VRF systems or VRV systems, you're not going to have a heating hot water boiler, so you would just leave this undefined. If your building has a heating hot water boiler providing hot water to a built-up system as well as a VRF or VRV system, you would define the heating hot water boiler here. Clicking on this undefined box takes you to our boiler library. And then in the domestic hot water tab is where you would select the boiler which provides service hot water to the sinks and the showers and that sort of thing. So I'll just select the standard one here. And we have the hot water the service hot water there. For lead projects, under the renewables tab, you can enter your renewables. And then under the exceptional tab, if you have something else that you think deserves credit and you can prove to the USGBC, you can enter that information here, and it will be included in your final results. These tabs, the chilled water and the hydronic, are for built-up systems. We're not going to go into this much detail today. If you have any questions, let us know, but you put the cooling tower and the chillers here under this tab. So once you have the plant icon, you're going to need to build a system. Again, you'd right-click on what I have called undefined plant right here and select Add System. You have an undefined system where you can change the name, You can select if it's new or existing or removed or altered. And then by clicking on the new system, you get into the default library. Now this is the default library. It's not going to have the VRF and VRV systems right now, just the way I have mine set up. If you change your default library, you can have all those systems listed here and you won't need to import them. And please let me know if I'm moving too fast or if there's something you want me to go over again, anything like that. So in this general tab of the system, you can list where your outside air comes from. If you have a dedicated outside air system supplying air to all your systems, you would select that there. We do have a dedicated outside air sample file, which you can view. We're not going to get into that much detail on that again today because we're concentrating on the specific systems. Okay, and then next in this system icon is the distribution tab. I know it seems weird that it says ducted here for these if we're doing VRF systems, but that's how it should be. The software calculates the correct energy usage of VRF and VRV systems with these listed as ducted. It's not going to change if you change it. The results aren't going to change if you change it to ductless. But if you're doing a separate type of system and it was ductless with a fan, you could change that there for the heating and for the cooling. Okay, after you have a system, you can either select to add a zone, or you can right-click on the plant and add another system. It's all right-clicking and adding. You can continue to build your model this way. For each different system type you have, you would add a different system, and then there's the multiplier of the system listed here. If you have 5 of those central systems, you could put the multiplier in right there. So moving along to the zone icon, this is where you would select the occupancy type. It's not going to be single family most likely. Let's say we're doing a complete building office. And then if you're running a 90.1 calculation, you also need to select lighting occupancy, which would also be office. Yes, for the VRF, all of the system inputs are going to be populated based on the library. We have those libraries, and all of the systems have all of the necessary inputs already selected. So once you import that system from the sample file to your file, you don't really need to change anything else. And I guess now would be a good time to show you how to import that. So I'm going to make my EnergyPro screen a little bit larger there. I hope it doesn't mess up your viewing. So what I'm going to do is I'm going to open, and then I have my projects folder right here. You can save your projects folder anywhere you want. I have it on my desktop. Once you open that projects folder, and then open up one of the manufacturer sample files, and then a little trick here is to go to Window, Tile Vertical. And what I want to do now is I want to get the systems from this Mitsubishi sample file into my project file over here. So I will open up the Central System Library. There's 2 ways to open up the Central System Library, either by clicking on the library here within the zone icon, system icon, excuse me, or you can go into the libraries here and zonal central. So let's say I want to use this system here. I'll select it. I'll hit export, and my building 1, which is the file I'm working on right here, is listed. Click OK, and the central system is exported. Now when I go into the library of my building that I'm working on, the system I want to use is right there. I'll select it, and that's it. All of the information is already filled out with the output for the heating, the output for the cooling, the fans. It's all there, and you shouldn't need to change anything. Yes, it takes into account the part load efficiencies. That's really the point of the VRF and VRV systems. So now we can also import a mechanical zonal system into the zone icon. Under the mechanical tab, you have your zonal system, and you'll notice that in my default library I just have CAV and VAV boxes, but in the sample file the zonal library has a list of the variable refrigerant flow systems. So if this is the one I want to use, I'd highlight it, I would export it, I would select the building I want to export it to, and now in my building the zonal library has that system included. Now you can highlight a system, hold down the shift key and highlight a number of them, then export all of them to your building, and then they would all be right there. What you will need to do is you will need to have a number of different zones under each of your systems that are VRF or VRV. So you'd right click and you'd add a zone, and these are just going to be thermally independent zones with either the same or different mechanical systems in each one of these zones. And you'll give each of these a different name, you know, like 5th floor east or 5th floor south. And then you need to start adding the envelope features to these zones. So you do right click on that zone and select add room. Now I'm going to shut this down. So we can see the entire screen here. So you have the room icon underneath the zone icon. This room icon, you can name it the same as the zone 5 east room. This is where you put the area. The area is the area of the conditioned floor area that you're modeling under that zone. So we'll say we have a 100 square foot room with an 8-foot ceiling. Not a lot else really needs to be entered into this field for LEED or for just general energy analysis projects. A lot of these are Title 24 inputs here that we're not going to go into today. Once you have the area and the height of the room, again, right click, and then you'd add the envelope features here. So you'd probably have a wall, you'd probably have an east wall in that east zone. That east wall might be 500 square feet. And clicking on the next to new assembly will take you to the assembly library. Right now I just have one assembly in my assembly library, so we'll go with that. And then the orientation is going to be east. The tilt is usually 90, but you can change that. If there's thermal mass on the wall, you can select that here. And then within the wall, you would right click and add a window or add a door. Enter the area of that door and window. The software will take away the area of the door and the window from the area of this wall here. So enter the gross area of the wall and then the gross area of the window and door, and the software will subtract the area here. That also means that it won't allow you to put a window that is larger than the wall area here. You'll get an error message. So a lot of the time your room is also going to have roofs and floors. You can go through and add as many of these walls and windows and roofs and floors as you want here. You can also add lighting to these rooms. The lighting will, you just need to select your your fixture. Really the watts is what matters. Select your fixture there. Select the multiplier. I might have 10 of those. And then the reference code, which will show up on reports, you might call that F1 if that's what it says on the plans. You can add a number of different lighting fixtures, F2 and so on. You can have a number of different walls. This room icon and adding the envelope underneath is really where most of the modeling is done in terms of what the load on the building is going to be. The orientation is really important, and yeah, I mean, can you apply a reference code to a window? No, you can't. It'll just be the list here. What's listed here? Which you can change this here. You know, you can call it Milgard or whatever you want to call it, and then, but it's not really like a reference code. So there's a question about the Title 24 forms and what they show there. Real briefly, I can show you what the Title 24 forms look like. So just take a second. You'll see the list of the windows here. It does just say window or skylight. These are California Energy Commission forms for Title 24. Not a lot of changes that we can make to these. I don't know why that is. That's just the way it is. Okay, so back to this sample file that I am building here. Let's say this is how I want to build my model. This obviously is very incomplete, but let's say I'm done with it. What you need to do is you need to select the calculation that you want to run, and to do that you come down to the bottom here, select calculations, and then there are these calculations here. The non-residential performance is just going to give you an energy usage of the building based on what you've input. It's not going to be based, on any standards. It's really just going to be a calculation of what the building is going to use. Then you might want to compare that to a whole nether building and see how the buildings compare. The NR 90.1 performance and the NR T24 lead modules are both lead modules. They will give you the EAP1 reports for lead, which you'll just have to transfer into the online lead template. The 90.1 module will base the calculation on a 90.1 baseline, while the Title 24 for lead module will use the Title 24 baseline. Only California buildings are allowed to use the Title 24 baseline, while anywhere in the country can use the 90.1. So another question is, if there's a VRF system model that's not in the sample file, can you add one? Yes, you can. You want to make sure that you get that information from the manufacturer and it's accurate. Then you can change it. What you don't want to do is change a couple things. This is variable refrigerant flow system. This efficiency, the 3.413, you want to leave that there. That's always going to be the efficiency. That is the conversion factor from kilowatts to BTUH. The total output, yeah, we're not going to go into that. Sorry. Okay. So you can add your system here. It's best to alter a system that's already a variable refrigerant flow. Don't select, split DX and try and change things. I would select one of these variable refrigerant flow systems and then make changes there. So back to the calculations. The NR Tile 24 performance is just for Tile 24. You're not allowed to use variable refrigerant flow or variable refrigerant volume systems for Tile 24 calculations, so you're not going to be running that. That may change in the future, but as of now, you cannot do that. So let's run, let's say we're going to run a 90.1 calculation. And then what you need to decide is if you want to include the envelope, indoor lighting, outdoor lighting, mechanical, and domestic hot water in the scope. If not, you can just uncheck the indoor lighting and outdoor lighting maybe, and leave the rest selected. Next, you want to go to the reports button underneath calculations and select the reports that you want the file to include. It's got to be matched up. You want to match up the report you select with the calculation you select. So I selected 90.1 under calculations. I'm going to select 90.1 under reports, expand that, and select exactly which pages of the report I want to include. Now you can only select one report, while you can select a number of different calculations to run at the same time. So you can compare your building to the Tile 24 baseline and the 90.1 baseline at the same time, see which one gives you a better lead report, and then go with that one. So that's a real quick overview of how to build the building tree, build the model. If there's any other questions in regards to that, now might be a good time to ask those. For Tile 24 performance, if your building is going to be using these variable refrigerant flow systems, you do need to change the system type to a split DX heat pump with a 13 SEER is what you need to do. Just like that. That way the software will calculate a regular split DX heat pump, and the California Energy Commission will be happy with that. So I'm going to go back to the sample file that I had open earlier, and I'm going to show you what the reports will look like. Actually, I don't want to use this one. I'm going to open the file I had earlier. Once you've selected your calculation that you want to run and the reports that you want to include, you come up to the toolbar and you hit calculate. And it'll take just a few minutes, a few seconds really, depending on the file. And you'll get down here the results of your calculation. So you have here the baseline 90 degrees, 180 degrees, 270 degrees, and your proposed results under heating, cooling, lighting, and so on. Then at the end you have the total. And you can see here that this building, with really nothing special or above standard other than the systems, is gaining 3 lead points just for having those systems in there. So take a look at those results, and this should make sense. Now, if you wanted to change something in the building, you maybe decided to use a different system, or even change the wall type. From R19 to maybe you're going to try R15, you will have to recalculate, and you'll get different results here. If you change something in the building tree and then you don't calculate and you go to view the reports, you'll get an error message. You should get an error message saying that the results are not current and cannot be viewed until you calculate again and then view the reports. The input data is always from the proposed building, yes. So the building that you are, is actually going to be built is what you input here, and then the software creates the baseline buildings based on the standards. It'll have the same square footage, it'll have the same window to wall ratio, it'll be in the same climate zone, but the either 90.1 or Tile 24 defaults will be used for these baseline buildings. Yeah, and then this proposed building is your actual real-life building, how it's going to be built or how it is built. So now that the calculation has completed and the results are shown here, you can go to the toolbar and click on the Print Preview button. Let me make sure I have my reports selected. I have the 90.1. I have the reports. You hit the Print Preview, and a PDF will be created of your report. So under the project, I don't have all the information entered, such as the designer and so forth, but it'll show up if you did enter it. And then you have the lead compliance reports, EAC1, EAPS, right here. Unfortunately, there's no way to get this directly into the online template. You just have to transfer it over. But we've created these reports to look as similar as we could to the online lead template, so transferring it is pretty easy. Now, we're not going to go over these reports today. They are lead reports for the most part, but this is how you would view them. You just hit the Print Preview. From there, you can save the PDF. So a common error that I see from users in modeling VRF systems is that they don't have the appropriate ratio of the zonal mechanical system here, zonal icon, mechanical tab. The ratio of cooling that's listed here for all of these zones needs to be between 50% and 200% of the output of the central system. So I'll show you what I mean there. I'm going to delete some of these systems just by highlighting them and deleting them. So you only have a few of those there, and you try and calculate, you'll get an error message. EnergyPro, the error messages are listed here. There'll be a description of the message and then a solution. Oh, it's 150%. I said 200, excuse me. And then you can click on the magnifying glass to see exactly where it is. It takes you there. I'm sure you all know the VRF systems, you really need to have a number of different indoor units connected to that one outdoor unit. So this right here won't work. There's not enough capacity of all these indoor units to meet that outdoor unit. So what I'm going to do is I'm just going to delete that system there and have just the one system in my model now. So say I have two group room / office zones here, and I don't want to go through the whole building of it with the room and all these walls again. I can right click and select copy and then highlight the system icon and paste it there, just like other Windows programs. I can also, as I showed you earlier, right click or highlight it and hit delete on my keyboard, or right click and select delete. And you can do that for just about any item in the building tree. You can move a window from the west wall to the east wall just by clicking on it and dragging it up. You noticed on the left that yellow arrow goes from a kind of a thin arrow like that when I'm on the window, because I can't drop a window into a window. But once I get the window into a wall, which I can move it to, the arrow turns to a thicker yellow arrow and I can move it there. Can a room be hidden from calculations without deleting? Not really. In the zone icon, under the General tab, you can change it from conditioned to unconditioned. The lighting will be taken into account, but the rest of the room won't be. There's no really other way to just remove a room. And once you turn a zone into unconditioned, all of the rooms will be set to unconditioned. Can you have two or more different zonal systems in the same zone? No, in EnergyPro you need to have just one system serving each zone. Now, fan coil units are oftentimes modeled as a central system, really. Model it there, and then you'd add the zone which it's serving an IDF room or whatever under that central system there. Now, Austin, I don't understand your question. Let me see here. I think it's the question above. Okay. Okay. So let me see what else I have here. All right, another problem people sometimes have is managing the library. Say you have two central systems here, and they are both using this P96, this last one in the library here. What's going to happen is if I change the information on this P96 here in the right pane of the library, it'll change the information for every system that has this P96 selected. So let's say I'll change this to 200 and 8000. Since this system has the exact same library selection, it's going to be 208 here as well. What you need to do is you need to create a different library entry. Once you hit the add new, a copy of whatever was highlighted will come up with just a copy of, and you might want to call it 208 or something, and then change the output under the original one. You can leave that as the 100, and now you'll have the 108,000 output under that system and the 208 output under that system. People have that question quite a bit. Can you briefly explain how to model a wall that has an adjacent multi-story building? Sure. Well, you really wouldn't model that adjacent building. What you can do in EnergyPro in the room icon is you add an exterior wall or an interior surface. When you add an exterior wall, it's obviously going to be a wall between conditioned space and unconditioned space. You don't need to model any walls that separate two conditioned spaces in EnergyPro. You can and should model walls that separate a conditioned space from an unconditioned space, and you use an interior surface for that, such as a demising wall. I'm getting error messages here, but we can just ignore those. So once you select that interior surface, you would put the area in, you would select the assembly type, maybe it's an R0 wall, and then you need to select the adjacent to. This adjacent to is going to be an unconditioned zone. And since this model right now doesn't have any unconditioned zones, I'm going to add one. Right-clicking, add zone, this unconditioned zone, unconditioned. Still an office. Then back to the interior surface, adjacent to, you would select the unconditioned. Actually, what you need to do, you need to add a room to that unconditioned zone and put the area. Maybe I have a 80 square foot unconditioned room, and in the interior surface, you would add the unconditioned. You'd select the unconditioned room. You really don't model the adjacent buildings next to exterior walls. I guess the assumption is there's still going to be a little air gap and there's going to be heat transfer going on through there. So if the unconditioned room has a heat source in it, sensible heat, latent heat, process equipment, you can enter that here in terms of watts per square foot. Fan unfunctioning. Ali, I'm going to look into that one. Is there credit taking for shading other than an overhang? So in the window icon here, there is the exterior shading tab. You can select from these shading devices, or you can select an overhang or a side fin. So the overhang library has the name, the horizontal projection. Maybe I have a 12-foot overhang, maybe I have a 2-foot overhang, the distance above the window, and then how far it goes past the left and the right. Kind of the same thing for the side fin. Side fins are vertical. If you're modeling a side fin and you have a question about the right fin and the left fin, it is if you are looking at the window from the outside, or if you're looking at an elevation of a plan, the right and the left is from that reference point, not if you're looking out the window from the inside. Is there a credit for taking machine? So there will be heat transfer from unconditioned to conditioned. Yeah, that's why you need to model those unconditioned areas. And in terms of the multi-floor buildings adjacent to your building, in this assembly library, there is reflectance and emittance, so you can kind of show no heat gain there by making that one. You can also model it as north. That'll do away with the heat gain on that wall, but there's really no way of directly saying that there is a big multi-story building right next to your building shading it all the time. So we just had someone join. We are recording this, and we'll give that to you later. If you have any specific questions after the webinar, you can email those to support@energysoft.com, and we can get back to you that way. That's really the best way, I think, to do it, is to email support if you just joined, or wait for that video. We'll have that available sometime in the future, hopefully soon. Okay, so feel free to keep asking questions. I'm just going to go over a few other little tips in EnergyPro that you'd probably figure out, but if I show you now, it'll make it a little bit quicker. So managing the building tree, you can expand and collapse these things to see everything you want to see and nothing you don't want to see. Under the view, you can expand everything and see everything you have in your model. You can also right-click on, say, a system and say, show me just the systems, or show me just all of the zones. When you have a real big building like a hospital or something, it'll come in handy to do that sort of thing. Under tools and user information, you enter your name and your company address here, which will show up on the reports. The company name is linked to your license key, so that will be locked in there based on your license key information, which you'll receive an email from once you purchase the software. Okay, so good question. Where's the library that you are exporting the VRF equipment from? Is it already on your computer with a program, or downloaded from some third party? The answer is it's already on your computer. When you download the program, when you download EnergyPro, there will be a file, and I'll show you where that is. It'll be on your C drive. Now it's kind of different for different versions of Windows. I have Windows 7, so I have to go to Users and then My Name. What you really need to get to is My Documents. Within My Documents, there's an EnergyPro 5, and within the EnergyPro 5, there's a Projects folder. That Projects folder has all of our sample files right here, and included in those sample files are the files Mitsubishi and Daikin, LG, that have the systems that I was exporting. So C drive, and My Documents, EnergyPro 5, and Projects is where you get the projects that have the libraries. And again, different computers are different. I don't know if you'll have to go to Users and then your name, or for different operating systems, the path will be a little bit different, but get to Documents or My Documents, EnergyPro 5, and Projects. And there are the air-cooled for the AC and WC for water-cooled example files. And then there's also different sample files that you can take a look at, and if you're just starting modeling, it might help you out a little bit there. Outdoor lighting, residential, non-residential, metal buildings, so on and so forth. So there are certain load assumptions that are based on the occupancy you select. So this library stacks is the occupancy. When I add a room to it, this room is going to have the occupancy density and occupancy sensible and latent ventilation based on the library stacks here. It would be different if it was, an auto shop or something. Sometimes you'll build a zone and then go back and change the occupancy, and the occupant tab won't change here. What you need to do is you need to go to Edit and Replace, and then go to Load Assumptions, Next, Next, select Global from Cursor or Selected Branch, and that will reset all of your load assumptions to be based on the occupancy. The Edit Replace, you can also go through and select Construction Assembly and change every wall from R13 to R15 or whatever you want to change it to. Next, Global. So that Edit Replace can save you some time not having to go through and change everything. So for the outdoor units, the heating type selected, is it based on model number, or is that a user input? I'm guessing, let me see here. The heating type should always be electric resistance. I know it's actually a heat pump, but the way that these systems are built into EnergyPro, you need to leave that heating type at electric resistance, so that it's not really a user input, or it's based on the model number, I guess. It's always electric resistance. David, I will get back to you on that. And if there's a question, that I said I'll get back to you on, probably the best thing would be to send an email, so that way I have your email and your question, and we can get back to you. Support@energysoft.com. All right, so let's go over one more time how to get the systems into your model. So I'm going to close this. I don't want to save it. I'm going to open up a brand new project. This is my project here. I'm also going to open up, and we'll go through the path one more time. On the C drive, users, my name, my documents, get to the EnergyPro 5 folder. Within that folder is the projects, and let's say I want to use a Daikin water-cooled system. I would select the Daikin water-cooled example file. I have two projects open right now. I will go to Window, Tile Vertical, just to lay it out a little bit more nicely. And let's say that I want to go into the libraries and my essential system. Here I have the list of all the Daikin systems. Say I want all of them to be in my model, because I don't know exactly which one I want right now, and I want to use all of them. I'm going to select the top one, scroll to the bottom, hold the Shift key, select all of them in that library. Then I'm going to export. And where do I want to export it to? This building 1, which is the name of the building that I just opened. Okay. The export's complete. And in my library now, under Central, I have all of these systems that I have in my default library, as well as all of the Daikin systems that I just exported. So what I might do is I might delete all of these systems already in my library and have just the systems I imported a second ago in my library. I would also need to go into the zonal systems and export them, highlight them all, export it to building 1. And now my zonal library, once again, has all of the VAV boxes and CIV boxes that are in my default libraries, which I'm going to delete right now, as well as all of the systems that I just exported. Now, if I wanted to make things simple in the library here and delete everything, that's fine. The software will not allow you to delete the model numbers that you have selected in your model, in your building. So if you want to see just the models you have selected, try and delete everything. The software won't let you do that. So the question is, can you model emergency backup heat, either hot water or electric resistance, for extreme climate conditions and VRV? In the VRV, I'm going to expand this. In the VRV library here, the electric resistance is the backup. Yes, you can model that right there. In terms of hot water, I don't think I've ever seen that. I don't think you can do that, but the electric resistance is how you would do that. So if you have a question on an input and you don't really know what it means or what you should put in there, a pretty good trick is to put your cursor in the field and hit F1 on your keyboard, and a little bit of information will pop up as to what you need to put in there. Another part of the EnergyPro model that you can manipulate is the schedules. Under the Zone Schedules tab, you can input the schedules that you want your building to use. We have the 90.1 schedules included in there, and the Tile 24. You can always adjust that to be what your building is going to use. You can change the hourly information right here, and then you can right click, copy, and paste that throughout the week. You can also do weekly periods right here. If your building is a school and maybe it's going to be turned off for the summer, you can put the weekly periods here. These weekly periods start January 1st and end the date that's listed here. So what I have here is just one period all year long. If I hit the plus sign, I'll have 2 periods. This one would end on, say, July 9th, and then the next period would go from July 10th through the end of the year, and that obviously you can put a different schedule in there. You need to make sure that these numbers here are in chronological order. If you have December before any other month, the file will crash. So make sure that these numbers are in chronological order. The first one starts the first day of the year and ends the date here. Every schedule underneath starts the next day and ends the day listed here. The last one needs to end on December 31st. Also, something I want to mention is in the zone icon under the lighting tab, you need to select the use installed LPD if you want to actually model the lighting. Otherwise, use standard will basically just give you the exact same number for the proposed building as the baseline buildings, but if you use installed, the software will calculate the lighting that you have actually installed into your room icon right here. Also, in the zone icon lighting tab, if you have the watts per square foot given to you from another employee, lighting engineer, something like that, you can just enter that exact watts per square foot right here. You may need to prove that to someone else later, but the software will calculate that watts per square foot for the lighting. And then for the standard, you can do the same thing, but you usually want to just use the standard LPD. You have the tile 24 and the ASHRAE. So for VRV systems, there is an input for the pipe length. If I click there on F1, it'll say it is the pipe length from the outdoor condensing unit to the indoor unit. If I was running two calculations like I showed you earlier, I had them both selected here. This might, I have the wrong climate, so I'm going to close this down and I'm going to open up a new one. So for the calculations, let's say I want to run both lead module calculations here. Hit calculate. And you'll have two different tabs here, the NR toggle 24 for lead tab, and here in a second you'll have the 90.1 for lead calculation, and you can just go back and forth and see which one gives you the better results there, basically which one you want to use. There's also the loads calculation right here. It's a separate module. Once you select that and calculate, you will get the heating load and heating output, as well as sensible or cooling load and output of each of your systems. So you can take a look and see if your systems are meeting the load of your building. There's heating loads based on the location and the envelope, so on, of the building. Obviously you want the heating output and the cooling output to be larger than the heating load, and the cooling load, you can oversize that by however much you want. All right. Any more questions? Let me know. I know that was kind of a faster introduction, but I hope it'll help you get started at least. And if there's no other questions, I guess that will be our presentation for the day on the VRF VRV systems in EnergyPro. Yes, the under the cooling tab, under the heat recovery, that is based on the model number, if it has the heat recovery or not. The supply temp you can adjust. Make sure it's the correct number. The supply temp is right here for the cooling and here for the heating. I don't ever mess with that. It's 105 is what is pretty much always used for the heating, and for the cooling we have it as 52 listed throughout. That number can really throw off the calculations if it's incorrect. So it is a user input, yes, but I think 52 and 105 is pretty much the standard which you should go with all the time. Can we compare a VRF with a standard DX system in the same program? Yes. What you would need to do for that, let me see here, there's a couple different ways you can do it. The best way, in my opinion, would be to actually have two separate models. So this one I have here is the Mitsubishi, obviously. I've messed with it, so I'm gonna open it up again under my recents. And then also, let's say I have, I'm just gonna select the retail example. These two files I'm looking at right here have different envelope characteristics. If I was really going to try to compare the same building with different mechanical systems, I would obviously build a model using one of the systems, do a save as, and then just change the system. So I'd have two different models with the same envelope, same location, but different systems. And then what I would do is I would use the tools lifecycle cost tool. This lifecycle cost tool allows you to compare two or more different models in terms of the energy usage and the price. So this is the lifecycle cost tool. You would have the base case, and then maybe you'd call this one VRF, and then maybe you'd have a third that's some other type of system. And for each one of these, you would select the calculated results from an EnergyPro run here. So for my base case, say I want to use the retail example. And for my VRF case, I want to use one of these VRF examples. Then I could do a number of these here, and once you go to the print preview, it'll give you a comparison of the two buildings, the life cycle costs, the consumption of electricity and natural gas, and so on. And you can kind of get in here and take a look on your own time. Let us know if you have questions. I'm not going to go over it too much right now. That's a quick introduction to the lifecycle cost tool. You can get as complicated as the discount rates, the study periods, so on and so forth. So that's, in my opinion, the best way to compare different systems with the same building. And does the heat recovery system, does the program take care of energy transfer from different zones? I guess meaning different zones within the building. Yeah, Ollie, I'm not exactly sure on that one. The library is saved with the file. So if you adjust a library and then save a file, whenever you open that file, the library will come with it. So what you can also do is under Tools, Default Libraries, under the Central System, you can just set this up to be your default libraries. That will be the library that shows up with each of your project when you open up a new project, if you always use the same systems. That way you don't have to export every time. Oh, one more thing. There is a 50 hertz system in the sample files. This Daikin ME example, it's for Middle East, but it really can be used for anywhere with a 50 hertz electrical supply. That's what the ME stands for here. All right. I hate to keep people waiting here. If you have any more questions, feel free to ask me now. No, Austin, I don't. I wish I did. I don't. The question is, if you can't read it, do you know what is holding up the VRF system for Title 24 compliance? No, we put together an application to get the VRF systems approved by the CEC, and I don't know exactly what the holdup is. Okay. Thomas asking if there's a certification FPDF for attending this webinar. No. This is just kind of a webinar that we're putting out there to try and get the information out. This webinar was recorded, yes, and we'll be posting it somehow. I'm not sure exactly what we're going to do with that, yes, but it is recorded. We do these webinars a few times a year. I don't know when the next one is going to be. We may be kind of ramping up the webinars to try and get more information out there. Yeah, I wish I had more information on that. Sorry. Just stay tuned, and we'll see when the next one is. I think the best way to stay up to date with the next webinar would be our Yahoo support group. We have a calendar on our website with the webinars that is under construction right now, but we post to the Yahoo support group the webinar schedules usually. Just go to Yahoo support groups and look for EnergyPro. No, Austin, I don't know when the SCE schedule is released for EnergyPro classes. Sorry. How do I get training on cost comparison of existing boiler chiller compared to VRF is a question. I don't know if we're going to be hosting a webinar on that specific category. I kind of doubt it. Really, what you need to know is just how to model the boiler chiller, how to model the VRF, and then how to use the lifecycle cost tool. If you have EnergyPro, you can email support and they can help you with that. I don't think there's going to be any specific webinars on that, William. So the Yahoo support group, you just need to go to Yahoo, and then they have a groups. You could probably just Google search Yahoo support groups, and then look for EnergyPro, and then you'll just have to apply. We'll approve you, and you'll be a member of the Yahoo support group. I think it's yahoo.com/groups or something like that, and then just search EnergyPro. So exhaust fans in EnergyPro, in the room icon here, there is an exhaust fan tab, which you can put the exhaust fan information in. In the system icon, in the library, under the fans, there is a return fan. It goes back to the air handling unit. So you can put the return fan there. You can put the exhaust fan in the room icon, exhaust fans tab. All right. Any other questions? Support@energysoft.com. And I hope you enjoyed the webinar. One more question. Oh, a couple more questions. All right. Okay, so for a dedicated outside air system, there is you'd model the VRF system here, and then you have outside air from. And what you would need to do is you need to create another system, which you might want to call DOAS, and you'd probably have no heating, no cooling. You might want to call the system DOAS, and then you have the fans input there. And then for the HVAC system, outside air is going to come from the dedicated outside air system. What you need to do is just create kind of a dummy zone. You don't want to have it single family. You want to have it something commercial, and then kind of a dummy room with maybe 10 square feet or something, just so it has something in there, just so the calculation will run. And then the software will calculate this system getting its outside air specifically from this system. Now in our sample file there is a DOAS sample which you can take a look at to get a little bit more clarification on. The question is how do you model a dedicated outside air system? Basically, you'll just see that there's the dedicated outside air system, and these systems get their supply air from that system. So you'd make a new system and a dummy zone. You don't need to have any walls or anything on there, just a couple square feet. The zone with the occupancy selected, and then the information for that DOS here. It might even have heating. Yeah, you need to model these VRF systems as minimum efficiency heat pumps, 13 SEER heat pumps for tile 24. All right. Well, everyone have a great day. and I hope you have a pretty good grasp of EnergyPro now, and thanks for attending.